Hi everyone, this is your second video lesson. So at this point you have already completed your graphing practice page. Make sure you do that before you do this so you have a better idea of how to do these before you jump into word problems. So these are going to be real world situations where we're going to be graphing the sinusoidal functions, and then we're going to be using the graph and the equation to kind of make some future predictions about other things. So in our first example, you have your annoying younger sibling refuses to stop playing with a yo-yo. We are going to start a stopwatch, and at 1 second, the yo-yo is at its lowest point, and that lowest point is half a foot above the ground. It's going to reach its highest point at 3 feet above the ground, and that's going to happen 1.5 seconds later. And this process is going to continue over and over again. So your formula here to find your x scale, you can use this formula and also remember it's the same thing as pi over 2 divided by b. Your y scale, we're not going to call that. I'm just going to call that the middle of the graph. And that's the d value. Okay, so the I gave you guys the equation already. If you're in pre-AP, you were expected to find this equation, but just since we're using the same material for regular and pre-AP, it's already been given to you here. So I'm going to be referring to this equation that's here. So let's label everything. Remember that the back number, this is the d value, this is the middle of the graph, and this is happening on the y-axis. So I'm going to put 1.75 right here. I've got, this is my amplitude. So that tells me from 1.75, I'm going to go up by 1.25 units. So that's going to put me at 3. And I'm going to go down 1.25 units, and that's going to put me at 0.5. Okay. I want to pause here for a moment and talk about how this problem is a little bit different since it's real world. Usually that negative 2.5 that you see in the equation, that would be our starting point. But if you look back at the question here, it says at 1 second, the yo-yo is at its lowest point at half a foot above the ground. That means that on my graph, I need to include the time. So my time is sitting on the x-axis. I need to include the time of 1 second. If I go ahead and start my graph at the 2.5 like I normally would, that is not going to reflect the time that I want to include. So I'm going to go and I'm going to start it at that 1 second because that was kind of the first piece of data that I was given. And it's telling me that at 1 second, I'm at my lowest point, and that's happening at 0.5 feet. So my graph is going to be starting right here. Now, my x scale, the way that I'm going to figure that out is still going to be the same. So your b value is right here. It's that 2 pi over 3. So I'm going to take pi over 2 and divide that by 2 pi over 3. So we've got pi over 2 times the reciprocal, 3 over 2 pi. These pi's are going to cancel, and you're going to get 3 over 4, or 0.75 if you want to use the decimal version. So that means that each time I'm going to be adding 0.75 along the x-axis. So my next point's going to be 1.75, 2.5, 3.25, 4, okay, now, so this negative 2.5 that's here, if you want to use that as your start, you can think of it like this. Cosine usually starts high, so it starts at the very top. So if this 2.5 was your starting point, I would be all the way up here, okay? It also says that it's at its highest point, 3 feet above the ground, 1.5 seconds later. If my starting time is 1 second and I add 1.5 to that, it gives me 2.5, which is the time interval that I'm sitting at, and it's at its highest point. So that makes sense as well. That connects together. My graph, just to kind of connect everything back together, it's going to keep that same general cosine shape. So we've got this, and then we're just going to connect all those together. Let's zoom out. Okay, and there we go. So let's look at some application pieces. So at 2.5 seconds, how high above the ground is the yo-yo? Well, this is very easy. All you have to do is look at the graph at the x value of 2.5 or the time of 2.5. We should be at 3 feet because that's what the graph says. If you want to double check this, you could always plug the x equals 2.5 into your equation here, and if you put that in your calculator, you will end up getting 3 feet. That's our answer. How high above the ground will the yo-yo be after 20 seconds? So I do not see 20 on my graph, so I'm going to need to plug it into my given equation this time. Okay, and if you type this in your calculator, you should get 2.75 feet. Remember that I posted that announcement that has the free TI software that you can download. Also, if you go on Desmos, their website, you can do graphing and calculation stuff on there as well, and that's free as well. Okay, next we've got a lance problem. So we've got a lance stuck in a windmill blade, and our character is stubbornly holding on to it. 5 seconds later, he is at the highest point in the blade's rotation, and he makes 6 full rotations in 1 minute. At the lowest point, he's at 3 feet above the ground, and the blades have a length of 10 feet. So this is a lot of information in one question. Again, I've provided the equation for you here, so we can kind of use this as a starting point as well. So let's start sketching based off of this equation. I'm going to do first. Let's do this point. Remember, this is the middle, and this is going to go on your y-axis. This front number, this is my amplitude. So I can either go 10 above 13, which would get me to 23, or I can go 10 below 13, which would get me to 3. This time, the 5 starting point, the question says 5 seconds later, he is at his highest point in the blade's rotation. This function is cosine. Cosine starts high, and my number that's here, the -5, this is my starting point. And since it's telling me I'm starting at the highest point, I can go ahead and flip the sign of that number and just put that 5 here, since it's already like going with the way that the graph is typically drawn. Okay, so we've got 5. To get my x scale, I'm going to do pi over 2 divided by b. My b value in this case is pi over 5. So we've got pi over 2 divided by pi over 5. I'm going to multiply by the reciprocal of the bottom. So the pi's cancel, and I get 5 over 2, or 2.5. So I'm going to continue to add 2.5 to all the numbers on the x-axis. Okay. And then my graph is cosine, so I'm just going to keep that same general cosine shape. And then connect all my dots. Okay, and there's our graph. So At 12.5 seconds, what is his height? Well, we can look at the graph. I see when my time is 12.5, my y value that goes with that point is 13. So I can say 13, and this is in feet, I believe. Yes, it's in feet. Okay. Or again, you could always take the x equals 12.5 and plug that into your equation, and it would give you the correct amount. Now, how high above the ground is he after 5 minutes? So the key piece here that's different from the other question is the word minutes. The equation that we're given is modeling in seconds. So before I plug that number into the equation, I have to change it into seconds, and then I can substitute. So 5 minutes, if I want to get that converted to seconds, I'm just going to do times 60, because you've got 60 seconds in a minute, and that's going to give us 300 seconds. Okay, so when I'm substituting, I'm not going to substitute 5, I'm going to substitute 300. Okay, and put that in your calculator. You should get 3.04 feet. Okay, last one. So this time, this is a more physicsy problem, I guess. We have a weight attached to the end of a long spring, and the spring is bouncing up and down. As it bounces, its distance from the floor is going to vary sinusoidally with time. So that's just a fancy way of saying that it has that, the shape of the graph that it makes looks like a sine wave. We're going to start the stopwatch. When the stopwatch reads 0.3 seconds, the weight is at the highest point of 60 centimeters. And then the next lowest point is 40 centimeters, and that's going to happen at 1.8 seconds. And then you've got your equation down here for reference. Let's go ahead and start graphing some of that stuff. So my 50, this is the middle. I'm going to put that on my y-axis. The 10 that's in the front, this is my amplitude. So I can go 10 above 50 and 10 below 50. So 10 above 50 would be 60, 10 below 50 would be 40. Okay. My negative 0.3 that's here, let's make sure that matches with what we've got. So it says when the stopwatch reads 0.3 seconds, the weight reaches a high point. Since this is a cosine curve, it's going to start high. So that negative 0.3 that's there, that is going to be my true starting point. And I know that at that point, I've got it up here at 60. Okay, I need to find my x scale. So 2 pi over 3, that's my b value. So I'm going to do pi over 2 divided by b. So I've got pi over 2 divided by 2 pi over 3. Multiply by the reciprocal. So the pi's cancel, and I get 3 over 4, or 0.75. So each time you're going to be adding 0.75 to your x value here. Okay, and my cosine curve is just going to follow the same general shape. That was really ugly. Here we go. Okay, so part B says predict the distance from the floor when you started the stopwatch. So what it's giving me is it's giving me that t that's in the equation is standing for time. So when time is equal to 0, that's when I'm starting the stopwatch. So I'm just going to plug t equals 0 into my equation. And that's going to get me 60 centimeters. Okay. This should say the height of the weight, not of the spring. It's a typo, I'm sorry. Again, this is just telling me that my time is equal to 15. So you are just going to substitute 15 into your equation. And that's going to give us 58.59 centimeters. Okay, predict the height of the, again, this should say weight, after 3 minutes. So just like on the other question, since our equation is using seconds as its base unit, we need to change this 3 minutes into seconds. So I'm just going to multiply it by 60. So that 3 minutes is going to be 180 seconds. So I'm going to be substituting time is equal to 180 into my equation. Okay, and that is going to give us about 59.6 centimeters. I guess I should put the about equal to because these aren't exact. Okay. So at this point, you've reached the kind of the end of the new material for this packet. You do have a practice assignment that goes with these word problems, but just to kind of explain for the last video of the week what the packet reflection questions are going to be. These are going to go into Skyward as a grade. The district is making it policy that we have to grade these. This is kind of our way of tracking that you're actually learning something when you're out of school. I would like it if you complete these with a minimum of 4 sentences, and they need to be complete sentences, not just like a bullet point of something. All of these we've already discussed throughout the lesson. If you want to use another resource, you can do that. Just please don't go on Google and verbatim copy some answer that's on MathStacks or something like that, okay? We would like you to respond to these questions on the Google form that has been posted to Google Classroom. Really, you should only be writing on these and turning it in if you don't have regular access to like printing these out or something like that. But if you have access to the Google Classroom, you should be answering these in Google Classroom, not on the hard copy, okay? If you have any questions, please feel free to reach out to me, Miss Serio, or you can reach out to Miss Lower or Mr. McGann. Y'all have a great day.